Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and related topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is thick cylinders, but it's also a mixed bag of possible exam questions, round 2, question 2. The formulas used are included in the video, and the question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP exams and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Okay, our question states, a simply supported beam is 4 meters long and carries a concentrated load in the center of the beam. The stress on the beam is limited to 80 megapascals and the deflection is not allowed to be more than 10 millimeters. Young's modulus for this material is 200 gigapascals, and the beam is made up by welding 2 channel profiles, 200 by 75 by 25.3 kg per meter toe to toe. What that means is that we have a beam. And our beam is welded right here in the middle. Okay, and now since this is a channel, it is a C channel. So what that means is that what I've done is basically shown this face on. This is face on. So this is the profile of a channel. This is the profile of a channel. And that is the profile of a channel. Give or take. Give or take. I'm not the world's best drawer. Okay. So now what the questions they want us to calculate are the second moment of area about both axes, the maximum concentrated load this beam may carry including its own weight, the actual stress and deflection of the beam for this load, and the force in a prop that is placed in the middle of the beam and 2 millimeters lower than the supports to prevent some of the deflection. Okay, so what we need is our values. So our values are length equals 4 meters, our stress in the beam, stress 80 times 10 to the 6, deflection is that, and the deflection is 0,01. Right, and Young's modulus, E equals 200 times 10 to the 9. And our channel profiles are 200 by 75 by 25,3 kg per meter. Right. Toe to toe means that both sections are welded end to end. It's a butt weld, basically. So, now our tables. Now we look at our hot rolled tables. First value is I small xx, which equals to 19,11 times 10 to the minus 6. A 10 to the minus 3 R equals 0.0499 squared y is equal to 1, 4, 7, 8 times 10 to the minus 6 and z equals 191, 1 times 10 to the 6. Alright, so that is all our values that we will need. So, now what we need to do is 3.1. Question 1 states the second moment of area about both axes. So, we want I, capital X, equals. Now what we're going to say is 2 times I, small x. The fact that we multiply this by 2 means that because there's 2 channels. Right, so this is 2 times 19,11 times 10 to the minus 6 equals 38, 22 times 10 to the minus 6 meters to the fourth. Right, we will need this value later on. 38, 22 times 10 to the minus 6. Okay, that's x. I, x, x. So now we got I, y, y equals 2 times I, y, y plus a, r squared. So now what we're going to do is say 2 times 1, 478 times 10 to the minus 6 plus a 3,218 times 10 to the minus 3 times r 0,0499 squared. And that gives us an answer. So I, y, y is our answer of 18,982 times 10 to the minus 6 m to the power 4. Okay, so I, y, y 18,982 times 10 to the minus 6. Okay, now we erase this because that is question 1. Okay, next question, question 2. Question 2 states the maximum concentrated load the beam may carry, including its own weight. So what we need first is M. So that is the stress times Z. Okay, so now we got M is equal to 80 times 10 to the 6 multiplied by 191, comma 1 times 10 to the minus 6, all in a bracket, multiplied by 2. And that gives us, it equals 30, 576. Kilonewton meters. Okay, so we have that. Now for the weight. How to calculate the weight, the self-weight. This is small w. How to calculate small w, because this is necessary for the next part of the sum, is 25,3 times 2 multiplied by 9,81. Because it's the self-weight of both of these. And because there's 2, you have to multiply by 2. So it's 25,3 in a bracket times 2 times 9,81. And that leaves us with a self-weight of 496,386 newtons. That's a solid number. 496,386 newtons. Okay. So our formulas will be thus. Right. M also equals big W, L, number 4, plus small w, L to the 3, to the 2 over 8. So, with that in mind, we have M, L is 4 over 4 plus W, which is 496,386 times 4 squared all over 8. And M equals 30,576 times 10 to the 3 equals W plus, let's get the sum, let's get that together, 496,386 times 4 squared over 8. That is 992,772 plus W, so a long W, a big W. So that minus this gives us W. So 30,576 times 10 to the 3 minus 992,772. And that is W equals 0.583 kilonewtons. Alright, so that is that weight taking your stress into account. Now we're going to take deflection into account. So it'll be a different W. It'll be a different W. But this one here is important for later. So big W, 1. I'll say W1. So it's 29,583 kilonewtons. So, what we're going to do next is take deflection into account. Now when we take deflection into account, it's two totally different formulas. Because so deflection equals WL3 over 48 EI plus WL 5WL to the 4 over 384 EI. That is our formula. So what we're going to do now is say 0,01 equals W to the 4 to the 3 over 48 times 200 times 10 to the 9 times I. Now I will be IXX. We'll take IXX into account. So it is times 38,22 times 10 to the minus 6. Plus 5 times 496,386 times 4 to the power 4 all over 384 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6. Now we're going to work out for W. Okay. Now how we do that is first take this one, get it all together, take that one, get it all together, and then just swap them over. Okay, so we're going to do this one first. So what we are left with is equal to 2. Now this is, we're doing the first one here. So we're left with 216,46 times 10 to the minus 6 for the first number. Now we're going to plus this number, which is 4 to the power 3 over 48 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6. Okay, this is 174,4 4 to 9 times 10 to the minus 9 W, which equals 0,01. So 0,01 minus 216,46 times 10 to the minus 6 equals 9,78354 times 10 to the minus 3 equals W all over 174,429 times 10 to the minus 9. So our W value is 9,7835 times 10 to the minus 3 over 7174,429 times 10 to the minus 9. And then we have W equals 56,089 kilonewtons. That is the weight with deflection. That is our weight with deflection. So just keep that in mind. Deflection will always be more than your weight with your stress. However, your stress weight is your true weight. Okay. Now they want the actual stress and deflection in the beam for this load. So now we're going to take the actual, now what we're going to do is the actual stress in the beam is quite simple. The actual stress in the beam, you don't have to do a whole long sum, you don't have to do a whole lot of equations or anything like that. The simple stress is 80 megapascals. The actual stress is 80 megapascals. Okay, now we want the deflection. Now we want our actual deflection. So that is deflection equals WL to the 3 equals 48 EI plus 5 WL to the 4 over 384 EI. Now, all you have to do is just plug in your values here. We have everything we need because we're using this weight here. So all we need to do is to get our deflection is 29,583 times 10 to the 3 times 4 to the 3 all over 48 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6 plus 5 times 496,386 times 4 to the power 4 all over 384 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6. Okay, plug all that into your calculator and your final answer is your deflection is equal to 5,377 millimeters. That is important for the next sum. So deflection, the actual deflection is 5,377 times 10 to the minus 3. Okay, last one. The force in the prop. We want the force in the prop at the middle of it that is 2 millimeters below the supports. So we have FL3 all over 48 EI. This is for a channel. So what we need to do now is take our deflections. So our true deflection is 5,377 minus 2 times 10 to the minus 3 equals F to the 4 cubed all over 48 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6. So we take all this up here and that down there. So what we're going to take is 3,377 times 10 to the minus 3 times 48 times 200 times 10 to the 9 times 38,22 times 10 to the minus 6 all over 4 to the power 3, and that all equals F. Now since we've done that, now we put all the values in our calculator and F gives us 19,359 kilonewton. And that is the force on the prop that we will need to. So whatever force is dragging it down over here, 19 is dragging it back up. So this is F. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.